Okay, let's think about the future of military flight for a second. It's definitely not standing still, is it?
Not at all. Things are changing fast. Global threats, new tech. It's a constant evolution.
Right, and that really pushes the need for, better ways to see and act from the air.
Precisely.
So today, we're going to dig into something right at that cutting edge. We're looking at the U.S. Army's Future Vertical Lift effort.
Big program, that one.
Huge. And specifically, we're zoning in on Lockheed Martin's concept for the attack reconnaissance part of it, the FARA competition. Their entry is the Raiderx.
Ah, yes, the Raiderx. Seen a bit about that.
Yeah, so our information today, just so you know, comes straight from Lockheed Martin's own website detailing the aircraft.
Good source material, though.
Exactly. And our goal here is really to unpack what the Raiderx is all about, what makes it innovative, and, why is it built this way for future conflicts?
Makes sense, because the why is crucial. It all ties back to that future vertical lift idea.
Which is the Army trying to, basically revolutionize its helicopter fleet, right?
Pretty much, yeah.
Yeah.
They're looking ahead, anticipating threats. Lockheed Martin specifically mentions dealing with evolving peer and near-peer threats in the most difficult environments.
Peer and near-peer threats. That sounds serious. We're talking sophisticated adversaries.
We are. It means the operational environment is getting much tougher, much more contested.
So it's not just about having a faster helicopter, is it? It's about survival and operating effectively when the enemy is, pretty capable themselves.
Absolutely. And it's also about the speed of change. The tech landscape moves so fast now.
You mean like needing faster upgrades, real-time decisions?
Exactly that. Aircraft need to be adaptable. You need the ability to bolt on new sensors, new weapons, new software quickly and without breaking the bank. That adaptability is key.
Okay, so that brings us right to the Raiderx itself. Lockheed describes it as a fast, agile, survivable, compound coaxial helicopter. That's quite a mouthful.
It is. Let's break that down a bit. Coaxial. That means it has two main rotors spinning opposite ways, one stacked above the other.
No tail rotor, then?
Nope. The counter-rotating main rotors handle the torque. That helps with stability and efficiency, especially in hover.
Okay. Coaxial. What about compound?
Compound means it has something extra for forward thrust. In this case, it's usually a pusher propeller at the back. That's what gives it much higher speeds than a traditional helicopter.
Ah, so rotors for lift and control, propeller for speed.
Got it.
And it's built by Sikorsky.
Sikorsky, yeah. They're a Lockheed Martin company, and they're the ones developing this Raiderx, specifically as a prototype for this FARA competition.
Right. Now, they talk a lot about the performance from their X2 rigid rotor technology. What makes that special?
Well, the rigid part is important. Traditional helicopter rotors have some flex, some flapping hinges.
Yeah.
A rigid rotor system is much stiffer. This translates, according to Lockheed, into highly responsive maneuverability. Think sharper turns, quicker responses.
More like a fixed-wing fighter jet in terms of handling.
Maybe not that far, but definitely pushing the boundaries for a rotorcraft. They also mention enhanced low-speed hover, off-axis hover, and level acceleration and braking.
Off-axis hover? What's that?
Imagine hovering while the nose isn't pointing directly into the wind, or even pointing somewhere different from the direction you're slightly drifting. More control authority at low speeds.
Okay, that sounds useful in tight spots. They claim it's unbeatable at the X. What's the X?
The X usually refers to the landing zone or the objective area in military terms. So they're saying in that critical close-in fight, its agility gives it a major edge.
Very confident claim. Unbeatable at the X. Okay, so the physical design is pushing limits, but they also stress the digital design and manufacturing side.
Yes, this is a really big theme in modern aerospace development, using advanced digital tools, 3D modeling, simulation.
Like building it completely in the computer first.
Essentially, yeah. You can model everything, simulate how it flies, how systems interact, test stresses, even model the manufacturing process itself.
What's the payoff for doing all that digital work up front?
Several things. You catch problems much earlier, which is cheaper to fix. You can optimize the design more thoroughly, and it speeds up the whole process.
They mentioned using similar methods on the CH-53K King Stallion, the F-35.
Right, these are complex programs where digital engineering has been crucial. For the Army, this potentially means lower acquisition costs up front.
And maybe easier upgrades later?
That's the idea. If you have a detailed digital twin of the aircraft, designing and testing an upgrade virtually becomes much faster and cheaper before you actually modify the real thing. It connects back to that need for rapid, affordable upgrades.
Makes sense. Building it smarter from the start for the long haul. Now, what about keeping these things flying? Maintenance is always a huge cost for military gear.
Definitely. And Lockheed says they're focusing on reducing operating costs here too. They're moving away from just scheduled routine maintenance.
Like change the oil every 3,000 miles kind of thing.
Sort of, yeah. The shift is towards self-monitoring and condition-based maintenance.
So the helicopter itself knows when it needs maintenance.
That's the concept. Using sensors and diagnostics to monitor the health of components in real time. Maintenance happens when it's actually needed based on the condition of the part, not just because the calendar says so.
Interesting. Like my car telling me the oil life is low.
Exactly, but obviously much more sophisticated. The benefit for the Army is potentially huge.
How so?
Well, you could reduce the sustainment footprint forward. That means fewer spare parts, fewer maintenance crews needed near the front lines. Logistics get simpler.
Okay, that's a big deal in the field.
And it leads to more flexible maintenance operating periods. The aircraft might be able to fly more hours between scheduled downtimes, meaning it's available more often.
Higher readiness rates.
Yes, dude.
Got it. Okay, another acronym they talk about a lot is MOSA, Modular Open System Approach.
MOSA. Yeah, this is a really important concept the military is pushing across many systems, not just aircraft.
So what's the core idea? Open and flexible.
Exactly. It's about designing the aircraft, its hardware, software, interfaces, using agreed-upon standards. Think of it like standard interfaces on your computer, like USB or Ethernet.
So you can plug things in easily.
Pretty much. It means you're not locked into one specific vendor for a particular black box or piece of software.
Okay, I see.
The goal is to make it easier to integrate components from different suppliers, upgrade subsystems independently, or insert new technology faster. It's that plug-and-play idea.
So if a new, better sensor comes along from Company B, you don't have to completely re-engineer everything from Company A to make it fit.
That's the ideal, yes. It encourages competition, which can lower costs, and it allows the Army to get new capabilities fielded much faster. More affordable, higher readiness, quicker upgrades. That's the promise of MOCAS.
And the Army is actively checking this works. You mentioned verification demos.
Yeah, they're planning demonstrations to make sure these open architectures deliver on that promise in the real world. It's a big push.
Okay, MOSA for flexibility and future-proofing. Now, looking even further ahead, Lockheed talks about the X2 technology itself having growth and mission flexibility.
Right, they see the core tech, the compound coaxial design, as inherently scalable.
Meaning the Raiderx for FARA might just be the beginning?
That seems to be their perspective. They highlight unmatched potential and growth margin for things like more speed, longer combat radius, carrying heavier payloads.
So you could potentially stretch the design, maybe make bigger versions for different roles later on?
That's the implication. The underlying technology allows for creating, as they put it, a broader range of aircraft configurations for specific mission requirements down the line. It's about building a platform with room to grow as threats evolve.
Very future-focused. And just bringing us right up to date, there was recent news about the engine, right? The ITEP.
Yes, that was significant. In late 2023, they announced the installation of the Army's new improved turbine engine program engine, the ITEP, onto the Raiderx prototype.
And why is that engine important?
Well, the engine is literally the powerhouse. The ITEP is designed to be more powerful, more fuel efficient, and more reliable than current engines in that class.
So getting that specific engine integrated is a big milestone for the prototype.
Absolutely. It shows the program is progressing, mating the advanced airframe with the advanced engine it's designed to use. It's crucial for hitting those performance targets we talked about: speed, agility, payload.
Okay, wow. So let's try and wrap our heads around this. We've looked at Lockheed Martin's Raiderx. It's their bid for the Army's Future Attack Recon needs.
Correct. Part of that bigger FEL initiative.
And the key ideas seem to be, well, first, raw performance speed and agility from that compound coaxial X2 design, that whole unbeatable at the X thing.
Roughly a core focus, yeah.
Pushing the flight envelope.
Then there's the whole design philosophy, using digital tools to build it smarter and faster up front.
Digital engineering for efficiency and future upgrades.
And making it sustainable with that condition-based maintenance idea.
Right, reducing the logistics tail and keeping it flying more often. Plus, building in adaptability from the ground up with MOSA, that open systems approach.
Crucial for staying ahead of threats and controlling costs long-term. Plug-and-play capability.
So it really feels like a package designed to tackle those evolving pure threats head-on.
That's certainly the goal. The Raiderx is a fascinating take on where military helicopters could be going. It's a significant step beyond current designs. aiming for that edge in really difficult future scenarios.
It really does make you think, doesn't it? When you see these kinds of leaps in aviation tech, like the Raiderx, it's not just about a new military helicopter.
No, it has broader implications.
Yeah, like how does this change the calculus of aerial operations? Or even, what other uses could this kind of high-speed, agile, vertical lift tech find eventually? Civilian applications, maybe? Security challenges we haven't even thought of.
Good questions. It definitely pushes our understanding of what's possible in the air. Definitely something worth keeping an eye on as these technologies mature.
Sure. Plenty to think about there.